Welcome to Azure Simplified. We will be looking into below concepts. Designing for backup and recovery. Key principles of backup and recovery. Factors to consider in backup strategy. Designing for Azure Backup. Overview of Azure Backup Service. Best practices for Azure Backup. Designing for Azure Blob Backup and Recovery. Backup strategies for Azure Blob Storage. Recovery options for Azure Blob Data. Designing for Azure Files Backup and Recovery. Backup strategies for Azure Files. Recovery approaches for Azure Files. Designing for Azure Virtual Machine Backup and Recovery. Azure VM Backup features. Recovery methods for Azure Virtual Machines. Designing for Azure SQL Backup and Recovery. Backup strategies for Azure SQL Database. Recovery and restore options for Azure SQL. Designing for Azure Site Recovery. Overview of Azure Site Recovery. Implementing Azure Site Recovery for business continuity. Importance of reliability and recovery. Organizations need high reliability for mission-critical apps. On-premises reliability is achieved through redundancy, extra servers and storage. Apps must be recoverable after a failure via backup and restore procedures. Azure and hybrid environments require additional considerations. Reliable apps should be resilient to failures and maintain high availability with minimal downtime. This table outlines key considerations for designing a backup and recovery strategy for mission-critical applications. Here's a breakdown of each factor. 1. Workloads and usage. Different workloads, distinct tasks or services, have unique requirements for availability, ensuring they remain accessible. Scalability, handling varying demands. Disaster recovery, recovering from failures. Understanding these factors helps in planning redundancy and failover strategies. 2. Usage patterns. Workload demands vary during critical and non-critical periods. Example: an e-commerce app may need high availability during peak sales seasons but can reduce resources during off-peak times. Identifying these patterns helps optimize redundancy and cost efficiency. 3. Availability metrics. MTBF, mean time between failures, measures how long a system component typically runs before failing. MTTR, mean time to recovery, the average time needed to restore functionality after a failure. These metrics help determine where redundancy is required and set service level agreements, SLAs. 4. Recovery metrics. RTO, recovery time objective, maximum acceptable downtime after an incident. RPO, recovery point objective, maximum acceptable data loss in case of failure. RLO, recovery level objective, defines what needs to be recovered, e.g., an entire system, a single app, or a specific database. These metrics help businesses assess risks and implement appropriate backup and recovery strategies. 5. Workload availability targets. Each workload has different availability needs based on business priorities. Setting target SLAs ensures that critical workloads receive the necessary uptime and resilience. This involves balancing cost, complexity, and dependencies. 6. Service level agreements, SLAs. Azure SLAs define Microsoft's commitments to uptime and connectivity for cloud services. Businesses must ensure that the SLA aligns with their own uptime needs to avoid service disruptions. Example: if a business requires 99.99% uptime, but an Azure service provides 99.9% uptime, additional redundancy may be needed to compensate for potential downtime. Key takeaway: this table provides a structured approach to designing highly available and resilient applications, ensuring that businesses can recover from failures with minimal disruption. Overview of Azure Backup. Azure Backup uses Azure resources for short-term and long-term storage. Azure Backup minimizes or even eliminates the need for maintaining physical backup media. Explanation of Azure Backup Service Diagram. The diagram illustrates how Azure Backup Service centrally manages backup operations for both on-premises and cloud-based workloads. 1. Key components of Azure Backup Service. Recovery point management manages restore points for efficient data recovery. Storage management handles data storage in Azure Backup Vaults or Azure Recovery Services Vaults. Resiliency and availability ensures high uptime and fault tolerance. Data tiering optimizes storage costs by automatically moving older backups to lower cost storage. Multi-user and multi-factor authentication enhances security by requiring multiple levels of verification. Policy management defines backup schedules, retention periods, and rules for data protection. Access control uses Azure Role-Based Access Control, RBAC, to manage user permissions. Monitoring and reporting provides insights into backup health, failures, and performance. 2. On-premises backup, left side, uses backup agents, such as MAS, MABs, or DPM, to backup files, folders, and system state. On-premises virtual machines, VMs, workloads like SQL databases. 3. Cloud Backup, right side, built-in Azure Backup protects Azure Virtual Machines, VMs, Azure Files, SQL Server, and SAP HANA in Azure VMs. Cloud Applications and Workloads. 4. Central Management, bottom section. The entire backup process is centrally managed via Azure Backup Service, allowing organizations to monitor, configure, and secure backups from a single control plane. Key takeaway: Azure Backup Service provides a secure, scalable, and centrally managed backup solution for both on-premises and cloud-based environments, ensuring high availability, cost optimization, and strong security controls. Azure Backup Storage Vaults. Azure Backup stores data in a storage entity called a vault, which includes backup copies, recovery points, and backup policies. Two types of vaults exist. Azure Backup Vault supports Azure Database for PostgreSQL, Azure Blobs, and Azure Disks. Azure Recovery Services Vault supports Azure VMs, SQL databases, SAP HANA, and Azure file shares. It works with Azure Backup Server, Azure Backup Agent, and System Center DPM. Considerations for using storage vaults. Vault organization. Use a single vault if workloads are in one subscription. Use multiple vaults if workloads are spread across multiple subscriptions. Azure Policy. Use Azure Policy to apply consistent backup policies across multiple vaults. Role-based protection. Secure vaults with Azure Role-Based Access Control, RBAC, to manage user access. Redundancy options. Locally redundant storage, LRS, protects against failure in a single data center. Geo-redundant storage, GRS, protects against region-wide failures by replicating data to a secondary region. Key takeaway: Azure Backup offers a scalable, cloud-based backup solution with various backup options, storage vaults, and redundancy features, making it a cost-effective and reliable disaster recovery strategy. Azure Backup provides operational backup for Azure Blobs, a local backup solution where backup data remains in the source Azure storage account instead of being transferred to an Azure Backup vault. Key features of Azure Blob Backup and AMP: recovery, continuous backup, no need for scheduling, all changes are retained for a defined period. Soft delete, protects against accidental deletion or corruption by allowing restoration within a retention period, 1 to 365 days, default, 7 days. Blob versioning, maintains multiple versions of blobs, enabling restoration after modifications or deletions. Point-in-time restore, restores block blobs to a previous state, reverting unwanted changes or deletions. Resource locks prevents accidental deletion or modifications through two lock levels, cannot delete, allows edits but prevents deletion. Read-only, restricts all modifications, similar to the reader role in Azure RBAC. Designed for Azure Blob Backup and Recovery. Implementation considerations: soft delete and AMP, versioning. Protects individual blobs, snapshots, or containers. Enables restoration within the retention period. Useful when multiple authors edit the same file. Point-in-time restore. Reverts a dataset to a previous state. Ideal for testing scenarios requiring rollback. Resource locks. Prevents accidental deletion of important resources. Can be set at cannot delete or read-only levels. Azure Blob Storage Backup ensures data protection, security, and recovery flexibility for organizations using Azure Storage. Azure Files enables share snapshots, providing an additional layer of security against data corruption and accidental deletion. These snapshots serve as a backup solution for disaster recovery. Key features of Azure File Share Backup and AMP, recovery, share snapshots. Capture the state of a file share at a specific point in time. Snapshots can be created manually, via Azure Portal, API, CLI, PowerShell, or automated using Azure Backup policies. Snapshots are incremental, only changes, deltas, are stored. Cannot be modified once created but can be read, copied, or deleted. Deletion restriction. A file share cannot be deleted unless all snapshots are removed. Automated backups with Azure Backup. Stores metadata in the Recovery Services Vault, ensuring fast, built-in backup and reporting. Soft delete is enabled by default when Azure Backup is activated. Supports daily, weekly, monthly, or yearly retention policies. Things to consider when using file share backups. Instant restore. Select and restore individual files instantly using snapshots. Alerts and AMP, reporting. Configure alerts for backup, restore failures and track backup insights. Self-service restore. Use Windows VSS snapshots to allow advanced users to restore files. On-demand backups. Since Azure Backup runs once per day, consider manual backups for critical files created during the day. File share organization. Structure file shares based on data sensitivity, public versus internal, for better backup management. Code deployments take pre-deployment snapshots to revert to a previous version in case of bugs or application errors. Azure Files Backup ensures fast recovery, automation, and flexible retention, making it a robust disaster recovery solution. Designed for Azure Virtual Machine Backup and Recovery. Azure Backup provides isolated and independent backups for Azure Virtual Machines, VMs. It enables snapshot backups and recovery in case of data corruption or accidental deletion. Key features of Azure VM Backup and Recovery. Supports both Windows and Linux VMs. Specialized backup for SQL Server and SAP HANA databases with 15-minute RPO and individual database restoration. Backup process consists of VM snapshot creation. Snapshot transfer to a recovery services vault without affecting production workloads. Provides automated recovery point management and optimized restoration options. Supports application, system, and crash consistent backups. Encryption at rest using storage service encryption, SSE, supports Azure Disk Encryption. Considerations for VM backup and recovery. Backup schedule. Plan backup times to avoid peak production hours and distribute backup traffic. Backup frequency. Implement daily, short-term, and weekly, long-term backups. Use on-demand backups for urgent needs. Backup policies. Group VMs with similar backup requirements under the same policy. Plan adjustments. Continuously monitor and update backup strategies based on business needs. Restore testing. Perform practice restores to ensure backup effectiveness before critical failures occur. Storage performance. Choose underutilized storage accounts to prevent delays in restore operations. Throttling management. Use separate general-purpose V2 storage accounts when restoring multiple VMs to avoid performance bottlenecks. Cross-region restore, CRR. Restore VMs in an Azure paired region for disaster recovery, compliance, and testing. CRR also supports SQL and SAP HANA databases. This approach ensures reliable, efficient, and scalable backup and recovery solutions for Azure VMs. Designed for Azure SQL Backup and Recovery. Overview. Azure SQL Database and SQL Managed Instances provide automated backups to enable point-in-time recovery within a specified retention period. Automated backup process. Full backups, performed weekly, capturing the entire database and transaction logs. Differential backups, taken every 12 to 24 hours, storing only changes since the last full backup. Transaction log backups, occur every 5 to 10 minutes, enabling precise point-in-time recovery. Backup usage scenarios. Point-in-time restore, restores a database to a past state within the retention period by creating a new database on the same server. Deleted database restore, recovers a deleted database at the time of deletion or any earlier point within the retention period. Geo restore, restores a database in another geographic region to recover from a regional failure. Long-term restore, recovers a database from an LTR backup if long-term retention is enabled. Long-term retention, LTR, by default, backups are retained for up to 35 days. The LTR feature extends retention for up to 10 years using geo-redundant storage, RAR-GRS. LTR backups can be restored as new databases via the Azure portal or PowerShell. This backup strategy ensures data resilience, regulatory compliance, and disaster recovery capabilities for Azure SQL databases. Designed for Azure Site Recovery. Azure Site Recovery. Overview. Azure Site Recovery, ASR, provides business continuity and disaster recovery, BCDR, for applications running in Azure, on-premises, or other cloud environments. It enables automated replication, failover, and recovery of virtual machines. Key features. Azure VM replication, failover Azure virtual machines from a primary to a secondary region. On-premises VM replication, replicate on-premises virtual machines and physical servers to Azure or another data center. Workload replication, supports Azure VMs, Hyper-V, VMware VMs, Windows and AMP, Linux servers. Automated BCDR tasks, automates test file hours and monitors recovery effectiveness. Data resilience, stores replicated data in Azure storage, ensuring high durability. Recovery targets, achieves low RTO, recovery time objective, and low RPO, recovery point objective. Consistent failover, uses app consistent snapshots to capture disk and in-memory data. Non-disruptive testing, conducts failover tests without affecting live replication. Flexible failover options, supports both planned file hours, zero data loss, and unplanned file hours, minimal data loss. Custom recovery plans, sequences multi-tier app recovery with scripts and Azure automation runbooks. Integration with SQL Server and AMP, Azure Backup, works with SQL Server always on an Azure Backup for comprehensive protection. Using Azure with Azure Backup. Azure Backup protects files and folders, ensuring data recovery. Azure Site Recovery keeps workloads running by frequently replicating VMs. Together, they provide a complete BCDR solution, minimizing downtime and data loss. Azure Site Recovery ensures high availability, seamless disaster recovery, and minimal disruption for critical workloads.